For the next step, I want to identify these peaks. We've told it what formulation to use. Now we want to go to Analyze, and we're going to tell it to fit the peak profile so that we can look at grain size, and we can also look at the lattice constants and alignment for this material. So we go to Peak Fit Profile. We just click on it, and that was in the Analyze menu. And the most accurate way to fit these profiles, if you have a lot of peaks especially, you can either just tell it to fit all the peaks, and the program will automatically go through, find the peaks, and fit them. Or you can tell it what peaks to fit. And you do that by selecting in the upper graph, just left-clicking with your mouse and dragging over the peak region that you would like it to fit. Notice it zooms it in the bottom graph, and we can tell it to go ahead and fit that peak. And here, it gives us the D-spacing for this particular peak. And it also gives us the crystal size as well. So now we want to go to the next peak and fit it. I'll tell it to fit it by just hitting the Run button. And notice that it will give you where it thinks the peak actually lies. Sometimes it gives you multiple peaks there. Sometimes it may be redundant. Maybe it gives you a peak in an area that you don't want. If that's the case, simply click on the peak that you don't think exists in the actual data, and then you can hit the Erase Peak in the graph, and that will just eliminate it from the rest of your analysis. That's very helpful if you have any noise in the system as well. So let's go ahead and grab these other peaks, and we'll fit each one of these. Notice that one, that's a good example. It gave me two peaks here. It gave me one at 74.49. If I mouse down here, notice the red slide bar that exists right down here as I mouse around. And also down in this region, we see the 2 theta value. So I'll go on top of where I think the peak actually is, and it shows it at 74.13. If I go to 74.497, so 74.497 up here, that would be about this location. Notice I don't really see a peak here. There's what it thinks is a small peak there. Let's get rid of this one. It is questionable. It has marked it. And we will tell it to get rid of that one just by hitting Erase One Peak. That erased the wrong peak. That's not the one I wanted to erase. Try that again. There we go. And we'll tell it to fit all of them here in just a moment. To see what it comes up with. So we go to this one, analyze that peak, and it just gave us one, which is what we want. And tell it to analyze this peak. Fantastic. So now we have multiple peaks identified. Let's double click here to bring it back to the original. The one peak that we're missing though is this one that we erased by accident. So let's go here and go ahead and fit this one more time. Good, so we brought it back in. Now we have all of the peaks identified that we want. Alternatively, we could have just hit the All button and it would have looked at every one of the peaks that it thought existed in this region. Good, so now with this information, you may want to actually copy this and paste it someplace. You can paste it into Excel. One of the most favored places to put it is in Notepad. So we opened up Notepad here. Now let's just go and tell it to copy it, and we can copy all to the clipboard. So we hit Copy, go to Notepad, and we paste it. And notice that it gives you, because of the spacing between the materials or between the columns, it gives you a little bit of trouble in aligning these columns, but you can do that manually before moving on. Good, so we have that information. Now let's go ahead and look at the lattice constants for the copper material that we have. We have all of these identified. It will hold on to these values as we continue with the rest of our analysis. So I'm going to close out that program, or that window. And now we want to go to the menu file called Options. We go to Options and we choose Calculate Lattice Constants. When we tell it to calculate the lattice constants, now it's going to look at those peaks, and it looks at the 111 plane, at the 200. It looks at all of these orientations, and it gives us what the lattice constants are for those orientations that it has calculated from the data. Since this is a face-centered cubic material, all of these lattice constants should be the same as they are. And it tells us what the average lattice constant is here as well. We can copy this one now, and we can go back to our notepad and paste it. Now we have all the information both in Notepad and also in our data here. We can go up, we can save this. We can also save it as maybe an XML file or something. Let's just choose Save the pattern as a text file. I'm going to save it in the same file where all of the XRD data is saved. Now we have all of the analysis that we are going to show in the JADE software completed. There are many more functions in this software. We have just touched the iceberg in the terms, the tip of the iceberg in terms of what the JADE software can do. We encourage you to go further and look at additional capabilities within this software for your analysis.